Okay, so today I'm also going to be going over dimensional analysis. This is kind of a key math principle that you need to understand for chemistry. I'll try to make this as simple as possible because I know that I kind of struggled with it. So starting off, dimensional analysis it's really simple. You're just converting units. This is all unit conversion, right? And we'll get into prefix multipliers in a separate video, but the main idea with this is that you just want to cancel out the units given. Or you just want to cancel out units so that you are left with whatever you were trying to solve for, if that makes any sense. The way that I write this out, if I'm given 0.75 kilograms, for example, I would write that as the numerator because that's what's given. And the denominator is per whatever I'm looking for, right? Not in this instance necessarily. So most people will write this out as 0.75 kilograms. And if we're trying to convert it to grams, I would just do times, there's 1,000 grams and 1 kilogram. So 1 kilogram. And then these cancel out, so then I multiply 0.75 times 1,000, and that is 750, right? So the given is the numerator, and whatever you're solving for, whatever it's per, is the denominator, right? So for example, if I'm converting meters to centimeters, I know that 1 meter, I know that 1 meter is 100 centimeters, right? So if I'm converting 2.5 meters to centimeters, my given is 2.5, so this is wrong. So I put 2.5 meters over 1 just because that's how I like to solve it. That's what helps me because I write it out as a fraction. And then I write, I know that 100 centimeters goes into 1 meter. And so I'm solving for meters. So meters cancels out, right? So next I just have to solve 2.5 times 100, right? That's 250 centimeters. If we were going to go gallons to ounces, right? So this is another problem. 1 gallon is equal to 128 ounces. If I'm trying to convert 3.67 gallons to ounces, I would take 367 gallons, right? Because that's what's given. And it's equal to 128. So 128 ounces goes into 1 gallon, or is equal to 1 gallon. So gallon cancels each other out, right? So I don't have to divide that. Next, I just multiply 3.67 times 128, and I get 469.76 ounces. You want to line up the denominator and the numerator in a way that the initial unit cancels out. Does that make sense? And what you're left with is the solving unit. So for example, if I swapped these, I'm gonna kind of draw this out. If I swapped gallons to ounces, right? So if I wanted to do 3.67 over 1, because that's how I like to write it. Sorry, I don't know why I wrote an equal sign here. And then I would do 3.67 over 1 times 1 gallon. Let's make sure we label everything over 128 ounces, right? So ounces would cancel each other out. So now we're just left with gallon, right? So 3.67 times 1 is still 3.67, right? So we have to divide that. So 3.67 divided by 128 is equal to, let me look that up, 0.0287 gallons, right? Because ounces canceled each other out. We're trying to solve for gallons. So boom, we have 0.0287 gallons, right? If we were trying to do time, if we were trying to do days, right? If I was trying to convert days to seconds and I wanted to convert 23 days into how many seconds, right? Well, this is fairly simple. It's just the same thing over and over and over again. We don't need parentheses for this because multiplication is associative in this principle or in this situation. So first off, we have 23 over 1 because that's how I like to write it. Most people, again, just write it 23 times 24 over 1. So 23 over 1. Let's go through this slowly. Days cancel each other out. So 23 times 24. Hours cancel each other out. So then whatever that was times 60. And then minutes cancel each other out. So whatever that was times 60 again. And then boom, boom, boom. Multiply that. And now you have 1,987,200 seconds, right? So I hope that makes sense. Maybe I need to work through some of this stuff. So this is a real question that I kind of came up with. I just asked ChatGPT to write a question for me, and this is what it came up with. This is like a nursing question. This really pertains to nursing. So I'm doing nursing, so that's why I wrote it down. So a real question, right? A patient is prescribed heparin at 18 units per kilogram per hour, right? So the patient's weight is around 154, and the IV bag has 25,000 units in a 500 milliliter solution. And the question is, at what rate, milliliters per hour, should the IV pump be set at, right? So how many milliliters do we want to inject or pump into this person? First thing we want to do, we want to convert pounds to kilograms, right? Because that's what it is. It's 18 units per kilogram per hour. So we want to convert 154 to kilograms. All we're doing for that is if we know that 1 kilogram is equal to 100 or 2.2 pounds, or I'm sorry, if 2.2 pounds, vice versa, whatever, if 1 kilogram is equal to 2.2 pounds, we just know we're gonna cancel this out. Boom, boom. 154 times 1 is 154. 154 divided by 2.2 is 70 kilograms because those units canceled each other out. Now we're left with kilograms. 70 kilograms. That's our answer. Step 2. Now we got to see how many units per hour we actually need, right? We haven't gotten to the concentration yet, but how many units of kilograms do we need, right? All we're doing is multiplying this by our body weight, or by its body weight, by the person's body weight, sorry. So if it's 18 units over kilograms per hour, we just multiply that by 70 kilograms. That's equal to 1,260 units per hour. So that's how many we need per hour. Step 3, we can't just inject, 1,260 units of heparin into this person's body per hour, right? All we have to do is divide 25,000 units, because that's the amount in our bag, per and 500 milliliters, right? Because that's the solution in the IV bag. So all we have to do is divide that. We get 50 units per milliliter. So each milliliter contains 50 units. Step 4, since we know the amount of units he needs per hour, it's going to be the same thing that we were doing with dimensional analysis before that. Again, I like to write it over 1 just to make it easier for myself. We can see that units cancel each other out here, right? So all we do is multiply 1260 times 1 milliliter. Okay, that's still 1260. Then we divide 1260 by 50, and we can see that what we're left with is milliliters and hours. And boom, 1260 divided by 50 is 25.2 milliliters per hour. So this is how much 154, was that the correct weight? 154 pound person needs of heparin, right? If he's prescribed 18 units per kilogram per hour. But yeah, so I hope I made this super simple. It is a lot to go over. I was in the library for a minute just trying to understand all this. It can be complicated at first, but I hope I made this super simple to understand, of course. In the next video, I'll probably go over prefix multipliers and some other equations as well. But yeah.